This tutorial expands the postage stamp remote drawing client, and we're going to try to make a little GUI out of it. So I want to show you how to do that. If you recall, basically, we just had a blank slate, and every time we clicked it somewhere, it sends a message to our drawer, and it draws our little postage stamp graphic. However, we really don't see where we've drawn, or there's no sort of feedback. So let's add some feedback. We can quite simply make in draw. So let's first of all move the background back into draw, because we're going to need that. And we can quite simply just make a mouse follower in draw. You pick any shape really. In this case, maybe I'll have a little square. So let's do a no stroke. And let's do fill. Maybe fill it black. So that's 0. Okay, and then we'll do a square that follows our mouse. So it'll be at mouse X, and Y will be mouse Y. And then we'll make it, smallish, maybe 30, 30, something like that. So if you run that, we have our thing, and then the square follows our mouse. So that's kind of good. I think a couple adjustments need to be made. One thing is there's this thing called rect mode. And it allows us to determine what these coordinates as X and this Y refer to. So in this case, it's a mode called corner, which means that our X and Y will be the top upper left corner of our square. But let's change that mode, and we'll use all caps here. And we'll put it in the center. Of course, you can go to rect mode and find in reference, and it'll show you all the it'll give you the idea of what the center, radius, and corners are, the different rect modes. Okay, so that, and I think it's a bit too big, so let's make it 20 and 20. Okay, let's try that, and there we go. We have our little square. It follows us, and it shows us where we can probably even make it smaller. I think I'm going to make it about 10. Okay. All right, well, that's kind of handy. Now, it would be good to have some sort of feedback happen. So what we can do is maybe change its color, for example, and maybe its size too. So that would involve, generally when we want to do something like this, change some attributes through an action, like a mouse pressed or something like that. We need to have some variables instead of hard coding it. So for example, we'll make a int, an int, and we'll call this ms, like mouse GUI size, and make that equal to, say, let's see, let's try 10 for now. Okay, and then we'll have let's change its color too. How about that? So a color can be its own variables as well, and we call that color, and we can give it a name. We'll say MSCLR. Sorry, and then if you want to do that, we have to make it equal to a color. Okay, and we'll call that green or black. I said, right? Okay. So now we'll just fill that in. So instead of it being fill 0, we're going to have it be fill ms color. And we'll make that a variable so we can change it later. And instead of these being 10 and 10, we'll make them ms GUI size. Okay. So it should be more or less the same now. A little bit smaller. ms GUI size. Okay. So now when we press the mouse, we're going to keep all this because we're still sending this OSC message when we press the mouse. But let's also change as well. Let's change, let's change the color and the size. So when mouse is pressed, we'll say MS GUI equals, let's say 30. Make it grow. And then we'll say MSCLR equals COLOR. Let's make it turn, say, orange or something. Let's see. Oh, and this is handy. If we're not sure about colors, we can use this color selector, tools, color selector. Hello? Oh, there it is. Okay. And it'll give us a range of colors and tell us what the parameters are. So if I want orange, something like that, it's going to be something like 255.153.0. Okay. I can copy that, I guess. I'm not sure how it works, but maybe it works. And we were down here. MS color equals. Let's see if that works. Oh, right. It's the hex, but let's just use the RGB 255.153, I think, and then 0, and that'll be an orange. So it's going to change from black to orange when I press, and it's going to grow its in size. So let's try that. So, and then if I press it, it's going to grow to orange and grow in size. Okay. And then you can release it on the mouse release and just put it back to its original condition when you release the mouse. And that's kind of handy. So we'll change that back to 10, the mouse size, and we'll change the color back to this original color, which was black, and make it 0. So that's our feedback for when it's released. Okay. Now the next thing I want to do is let my GUI of everywhere I've clicked. All right. So and that's actually a little bit trickier than it would seem. So bear with me, and we're going to go through a few steps and actually learn a few new concepts, which actually we're going to use quite a bit. So this will be introduction to these things, and we'll go over it many times when we use them again in the future. Okay. So basically, the problem comes in that if I want, say, a point or some kind of dot or something that persists everywhere I've clicked, I have to sort of create those dots on the fly. I don't know where I'm going to click, and I can't hard code them in ahead of time. So basically, I have to sort of keep track of my mouse clicks, but also continuously draw dots where those mouse clicks have taken place. Okay. So what we have to do is we have to create a place to store these dot coordinates, right? We basically need an X and a Y. All right. So I'm going to use an array. An array basically is just a collection or a set of numbers, and you can have array follow basically the same things as single variables do, and they have data types, except instead of one single digit, so like for example in this integer MS GUI size, it's just that single variable refers to a single number. We can have a variable refer to a collection of ints. So let's go ahead and do that. We're going to have an int, and the way you designate that this data type is going to be an array is you use a square bracket notation. So we're going to have an array of integers, and we're going to call that array. So now the variable name doesn't refer to a single digit or a single integer, but it refers to the whole set of integers. So we're going to call this x's, and we'll just leave that there. And we're going to have another integer. We're going to call them y's. Okay, and we can initialize these arrays in setup. All right, so what we basically do is we say xs is going to be equal to a new int, and we have to declare a length or size of int. Okay, well in this case, since we have sort of a blank set and we're going to keep adding digits to it, I'm just going to make that the length of that array 0 for now. So it's doesn't have anything in it, but it's getting ready to hold things. And we'll do the same thing for ys equals new int and then 0 in brackets. And the number in brackets just refers to the initial length of your array. Now, if you knew how long your array was going to be, you can put a number in there like 5 or 10. But we don't know how many times we're going to click. Okay? So that's all good and fine. We have these empty arrays, and they're getting ready to store our x and y values for our clicks. Now, what we need to do is we need to add to this array every time we click on a dot. Okay, and we'll do this obviously in mouse pressed, because every time we press, we're going to add a new dot, and we're going to then draw it. Okay, so let's do something and look up these array functions. This will be helpful. If you go find in reference and you go to language, you'll notice a section called array functions, and it has these various things that you can do to your arrays. But basically, we want to append a value, so we're going to go to append. If we look at the example, we see, and you can always just run these examples if it's helpful. Close the color selector and just see what happens. See, we have a string SA1, which is an array of these strings, and then we have another array of strings which appends SA1MA. So then it prints SA2. So basically, if we run it, it prints SA2, which is OHNYCA, Massachusetts, Ohio, New York, California, and Massachusetts. So you see what happens is you have an array of strings, SA1, and then you append one to SA2. Okay, so I think that's basically what we want. I could be wrong. Let's see. Let me see what expand is, and we can look at this. Okay. Right. I guess we can use either one, really. Okay. So let's start and try the append. All right. So if you remember the syntax, it was something like XS equals append. So what array are we going to append to? Well, it'll actually be XS. Itself, XS. Okay. Right now, initially, it's a 0 value. There's nothing in there. But we're going to append to that, and we're going to append the mouse X. Okay. And so remember, it's just going to run everything once. So once we press the mouse, it's going to add a value to our array of values, and it's going to add this mouse X. So it's basically going to take itself and add onto itself this value. Okay, so we're going to do that same thing for mouse Y, the Y's, and they're going to append to itself mouse Y. All right, that's great. So now we have a way of creating points, or creating the coordinates, and storing them in our array here. Now all we need to do is draw. Okay, so this is one more step and another very important concept. Now, if you remember before in our previous project, let me just get it up here, and that would be the postage stamp. Okay, we'll just go to the solution here. The postage stamp had this sort of looping function here. And that really was to prepare us for the actual for loop. So basically it said number of lines is greater than 0, and we have an initial number of lines which was equal to 2. So if the number of lines is greater, if 2 is greater than 0, then it runs all this code, and then it subtracts itself. Remember, minus minus means number of lines equals itself minus 1. So if it's 2 here, 2 is greater than 0, yes. By the time it gets to here, it runs all this code, it draws a line, because here you minus 1 from itself, it's equal to 1. Then it goes back the next time draw runs, next frame. Is 1 greater than 0? Yes, it runs this, draws another line, and then it goes, it minus itself, and which is 0. 1 minus 1 is 0. And then 0 is greater than 0. No, it's not. So it only draws the 2 lines. Okay. So now we're going to learn what's called a for loop, which basically does all that business except in a sort of more compact form. And it does it all at once. So in that case, you wouldn't draw all your lines in the same frame, but you draw one line per frame until you got however many lines you designated. So if you had 10 lines that you wanted to draw, it would take 10 frames to draw this. The for loop does everything in the same frame, okay? And the syntax is simply like this. For, we're going to create a counter int, an integer counter, I equals 0, and it started at 0. And then we're going to create a condition, basically. It's kind of like a while condition. If int is initially 0, continue to run the loop while I is less than, and then we have to get a final count. So basically, if we put 10, it's going to run this for loop 10 times, or 0 to 10. So that's why it's not less than or equal to, it's less than 10. So count from 0 to 9. And then on the 10th thing, it says, well, I is not less than 10 anymore. So we stop the loop. Okay. But in this case, we want to count as many as there are entries into our coordinates array. So we'll say I is less than, and there's a shorthand for this. So arrays have their own function which looks up their length, xs.length. Okay. So while, as long as I is less than the length, xs.length, and then we tell it how to increment, how many steps to jump. So we'll say I plus plus, and if you remember, that is shorthand for I equals I plus 1. So every time it runs a loop, it will add 1 to I, and it will continue counting until I is no longer less than the length of this set. Okay, hopefully that makes sense. Now, what do we want to do? Well, for every x, and in this case, it should be y should be the same, because every time we add an x, we added a y as well. So we just use the x's. For every x, we want to draw an ellipse, a little point. So we're going to put some conditions in there. We're going to have no stroke again. And I like to do it for each of my new shapes. I like to go ahead and do a new one, because you never know when things intervene, and it might not have the stroke and the fill that you're looking for. So we're going to have no stroke, and then we're going to have fill, and well, we can just make these black as well, or in any color really. Let's pick a different color. Let's make them blue. How about that? Okay, and yeah, and that's fine. And then we're going to draw an ellipse, and this is going to be at x. Now this is where the array comes in. So we've assembled an array of coordinates, and we're going to call these coordinates in this for loop. So well, let me write it out, and I'll explain what I mean. So it's going to go to xs, and we use your bracket notation I, and ys I, and then whatever size we want. Let's make it 10, or even smaller than that. Let's make it 7. Okay. So let's go back through this. So basically, this for loop runs, and it inserts this counter I. You can use that as a variable within your for loop. And so it runs, if I is equal to 0, it runs once with I equal to 0. So it's x as 0, y as 0. And then it goes again, and it checks if 0, or it adds 1 to it. So it becomes 1. And then it checks if 1 is still less than the length of xs. If it's not, if there's only one entry, then it will stop. If there's, say, 5, it will keep going. So it's and then it'll be 1 this time. xs1, ys1, and then adds 1 to it. And so 2, xs2, ys2, etc., 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 until you reach the length of xs. Now, you may be wondering what this is then, xs square brackets 0, 1, 2, whatever the case may be. And that just refers to the index number of your array. So not only does your array store a set of values, but it indexes them, each of them. So if I have 5 x coordinates stored in my xs array, the first value, say it's 100, will be index number 0. It always counts from 0. The second entry, say, is 300. It'll be index number 1, etc., etc. Okay, so these are indexed. So this is a way of looking up by index number. I'm going to look at the first, the 0th, or the first item in XS, and it doesn't mean that that item is equal to 0. It just means that it's the 0 index. It could be, 700 or 1,000,000, something like that. And then it's going to look for Y0 and then Y1, X1, etc., etc. Okay, so this should draw the entire set of X and Y's, and that should do it. Let's give this a try and see if it works. So now I have my GUI. It follows. Every time I click, it should leave a blue dot. There you go. If I click, it leaves a blue dot. So while it seemed like quite a bit of code, and we learned quite a few new concepts to do a simple thing, it works, and hopefully you can understand why. So you can see everywhere you've left a trace. And I know in the assignment I suggest maybe somebody making a battleship type game, and this is maybe one of the ways you might do that. You can see where you are leaving so you don't click in the same place. Okay, and then you got that graphic feedback too, where it's growing into yellow, orange, that sort of thing. For a final, we'll put an image in. All right, so basically we're going to use this p image, and this is a data type as well. Basically calls an image, and I'll call this p image SNP. How's that? Okay. And you need to load the p image using a function called load image. Now your image actually needs to be in your data folder. So if you find your sketch folder, PS Remote Draw GUI, that's my sketch folder. That's where my processing sketch is stored within this folder, and they have to be the same name. And within this, you'll have a data folder. Now, the data folder might not be there, so you might need to create it. Just create a new folder and call it data. And in your data folder, you're going to put any pictures that you want to display. Okay. So once I have a data type, a variable, and I give it a name, I can load the image using that variable. SNP equals load image. And we're going to give the name of the image in quotations, a string. So it's called snoop.jpg. And don't forget the suffix. Okay, and it's going to load that image. And then the third step in drawing an image is you're going to actually draw the image in Draw. So you say image. Okay, and it's a bit reversed than what we're used to. But it's just like ellipse or rect. You're going to draw the image, and you're going to say not the name of the file anymore, but then the variable name you give it. We're going to draw the image SNP. And then we're going to give it a location. So it'll be mouse X, just like our rect here. It's going to be our image that follows our mouse X and mouse Y. Okay. And let's see what happens when we run that. Oops, what did I do? Semicolon typo there. Let's run that. Ah, there we are. And he's following us. And just like, remember, we had that rect mode. Image has an image mode too, so we're following the corner. But it'd be kind of cool if it looked like it was sort of coming out of his mouth. So let's try that. And we need to make him smaller. So image can have 2 more arguments as well, and it can have a size. So we'll make the size, say, 30 and 30, something like that. Okay. And we can adjust this mouse X and Y to compensate, and this will be a bit trial and error, to where the actual mouse pointer is. Okay, so right now, if mouse X and mouse Y will be the top left corner of the image, so we move it over a little bit, so maybe 15, somewhere to the middle, so mouse X plus 15. So that means it'll start drawing the image. Oh, I think it's minus, sorry. It'll start drawing the image 15 away from the mouse, so it's actually minus 15, right? Okay, so if this is where my mouse is, it will start drawing the snoop 15 pixels that way, okay, which is half of the 30 width. Okay, and the mouse Y, we're going to bring it almost down to the bottom, right? So if this is the Y where we'll start drawing the snoop, we're going to do Y and start drawing him up there, minus almost 30. So let's say minus 20. Let's see what 20 what it looks like. Okay, let's try that. And he's quite a bit smaller. That's good. And then, well, our actual mouse pointer is right on his face. So maybe we can just make it slightly over and down. So that means that instead of 15, we're going to say minus about 10. And then minus 25. Let's see what happens there. That's not too bad. Seems to be right on his mouth. Maybe just slightly to the left a little bit. So, and maybe make it bigger actually. So let's go 40 and 40. And let's see how that works. That's not bad. Maybe slightly down then. Minus 30. That looks pretty good. There you go. Okay. Well, there you have it. So we've learned to have sort of a reactive mouse GUI. And our first go was to make this expanding rectangle, change colors. And we also learned the fairly involved process of leaving points everywhere we click. And that really involves creating a set and being able to add to that set every time we press the mouse using the append function. And then also to draw that entire set, we would need to use a for loop because it has to actually iterate through the entire set to draw each dot every time. Because you remember that draw gets erased every single time. So basically, it draws a big rectangle over the entire canvas of color of your choosing, and then you have to redraw all the dots every frame. So it erases them, it redraws everything. So it redraws the rectangle, the dots, everything you have. And then we learned to put an image on, which is a 3-step process, but not as complicated as the using the arrays. Basically, declaring an image, loading the image, and then drawing the image, resizing it here, and giving it an XY coordinate where to draw. Okay.